Okay, good morning, everyone, and welcome to the second edition of DiPSCo's Reproducibility. My name is Vivian Grillo, and I'm honored to co-host this event with my colleague Miren today. Today, we are here to discuss the paradigm shift towards open science, transparency, collaboration, and accessibility in science, which is also the mission here at the Department of Psychology and Cognitive Sciences at the University of Trento.
Good morning, everyone. As Vivian said, my name is Miren Chenevert, and I want to thank you all for joining us today. As many of you may know, we are the first Italian journal club within the Reproducibility Network, just focused on the promotion of open science. So this local initiative within a global community is dedicated to fostering open discussions on topics related to open science, questionable research practices, old and new methodologies, and representation in science.
Exactly, and we're pleased to announce that our weekly seminars are open to everyone, including students, researchers, and the general public, and that the seminars consist of a 20-minute presentation by our colleagues, and then a 30-minute interactive discussion where you're all invited to share your ideas, your experiences, and so on.
All right, so to kick off our seminar today, we have our colleagues Alessandro Carollo and Francesca Anderle. They are PhD students at DiPSCo, and the floor is yours.
So thank you, Vivian and Miren, for your kind introduction. Today, Francesca and I will present a paper written by Simmons and colleagues and published in Psychological Science in 2011. In this paper, the authors shows how flexibility in data collection and data analysis allows presenting almost any result as significant. So as scientists, what we commonly do is that we aim to discover truth about the world, and to do so, we generate hypotheses, we collect data, and then we check whether these data align or contradicts the generated hypothesis. However, even though we always strive for accuracy, errors are inevitable. And one type of errors, as for the authors of the current paper, is particularly dangerous for our discipline. And this type of error is the false positive, so the incorrect rejections of the null hypothesis. And false positives are particularly dangerous because they are persistent in the literature, because failures to replicate previous findings are never conclusive and might be due to several reasons, and because the researchers are not really encouraged to try a mere replication of a previous finding. False positives are also waste resources because they inspire investments in fruitless research programs and in fruitless societal policies. And they also undermine at the end the credibility of our field and of science in general, I would say. So as scientists, what we like to believe typically is that we accept a minimal risk of being wrong when we make any inference, and of our conclusion being a false positive result. And we commonly set this minimal risk at the 5%. However, the current standards for reporting details of data collection and data analysis make false positive much more common than we think. In fact, the authors of this paper introduced the term researcher degrees of freedom to explain the fact that doing data collection and data analysis, we have to make many decisions, and that it is very rare, if not impossible, to make all these decisions before we even start collecting any data. So for instance, common doubts that we might have are whether our sample is big enough, whether we should collect more data, whether we should conversely exclude some data, and if so, how we should exclude some data. So what is the rule that we should follow? And other doubts that we might have are whether we should combine or whether we should remove some conditions or some variables that were initially included in our experiments. So whether all these and also other are decisions that we need to take during our experiments, it is very rare, as I said, to make this decision beforehand, and conversely, it's very common to explore several analytic alternatives during our data analysis. And it's also very common to report in the final manuscript only the ones that worked well. The funny and also concerning thing I would say is that we are also very good, so research showed that we are also very good at justifying to ourselves and to the public that the fact that these alternatives that at the end worked well were also the best option that we had during our data analysis. And the problem with this, of course, is that when we run multiple analyses, the likelihood of at least one having producing a false positive result is much greater than the 5% that we typically believe is. So to quantify this greater than 5%, the authors of the current study ran 15,000 simulations on different scenarios that represent common researcher degrees of freedom. And in particular, they chose 4 situations that that might represent the doubts that we commonly have when doing data analysis. So for instance, in the first situation, they showed that the flexibility in analyzing 2 dependent variables almost doubles the probability of obtaining a false positive results. And in the second situation, they showed that when we have a sample size of 20 observation per condition, and then we run a test after adding 10 more observation, the likelihood of obtaining a false positive result is increased by almost 50%. In fact, as you can see from the graph above on the right, when we have a minimum sample size of 10 participants per condition, and then we run a test for every participant that we add for each condition, we incur in a false positive result the 22% of times. And another misconception that is very frequent in research is the fact that if we run a test on a small sample size, and if that test results as significant, it will also be significant when we increase the sample size. Well, this is not the case because as is represented in the figure, we can have false positive results with small sample sizes. The authors then showed that in third situation where we control for gender or interaction of gender with treatment, we more than double the likelihood of obtaining a false positive result. And this is true also for when we, for instance, run 3 conditions and report the results for any 2 or all 3 of them. So if this was not enough, when we combine all these 4 situations, we are more likely than not to falsely detect a significant effect. So it's much more likely, we are much more likely to have a false positive result than not. And if this again was not enough, we have to keep in mind that these percentages are very likely to be underestimations, because in this case, in this paper, the authors only selected and checked the effect of these 4 degrees of freedom, while in common practice we have much more decision to make for our experiment. So now I will hand over to Francesca, that will present some possible solution to this, to the risk of having a false positive result in our studies.
Thank you. Simmons and colleagues in this paper give us some solution to overtake the problem of flexibility ambiguity in of degree of a research degree of freedom. Especially, they give us 6 requirements for authors and 4 guidelines for reviewers. About the authors, the researchers of this paper suggest to decide in advance the rule for terminating data collection. In particular, they must to decide this rule before the data collection begins. Another suggestion is regarding the sample size. In particular, they suggest us to collect at least 20 observations. In fact, like said Alessandro a little bit before, in the figure on the right of the screen, we can see 2 lines. The dark line represented a small sample size, while the gray line represented a bigger sample size. When we have a bigger sample size and have a lot of more observation, we can to decrease the percent of false positive in our results. Another solution for overtake this problem, the problem of research degrees of freedom, is regarding to be transparent in when we've written a paper. In particular, we must to list all variables collected in our studies. So the authors must to list, to report all independent dependent manipulating variable that we use, and also it's the same for the experimental condition. So we must to include all the condition, the experimental condition we use, or also the failed manipulation. In this way, it's possible to be transparent when we conduct a research, and for other research, it's possible to replicate the same study. About the statistical results, Simmons and colleagues suggest us to report the statistical results both when we have an observation that we eliminate in our study, but we must to report the statistical result both with this observation and without this observation. And it's the same when we use a covariate in our analysis, in our studies. The solution for reviewers, the suggestion for reviewers is regarding to be ensure that authors follow the requirements asking for the specific journal. The reviewers should be more tolerant of imperfection in the results, and reviewers should require authors to demonstrate that their results don't not hang on arbitrary analytic decisions. So when we report our results, we sure that these results is depending on an objective and a good analytic decision. And if reviewers is not sure that the data collection or analysis are compelling, the reviewers should be asked to the authors to conduct an exact replication of the same studies. In the process of defining this solution, the author, Simmons and colleagues, discussed other possible solution, but they think this other solution that now I presented to you is less practical and less effective than the solution that I presented before. The possible other solution regarding the correcting alpha level, in particular for using, for instance, the Bonferroni method of correction. But when we use this type of correction, it's unclear which and how many of degrees of freedom contribute to any given finding and introduce new degrees of freedom. This is the same when we're using a Bayesian statistic method. In fact, in this way, these offer a new set of analysis and require other additional judgments for the authors of research. The last two solutions that the authors rejected is regarding the conceptual replication of the studies. When we use a conceptual replication, this method changes across the studies, so it's not the same for the same studies. And for the author, it is important to posting materials and data, the original materials of the studies, but if a paper tends to delete some information, for instance, about the non-statistical significant results, it's possible also to delete some information about the original materials. And in this way, contributed to a high cost on readers and reviews to examine the credibility of the research of what to say the researcher in the paper. The important the important aim of a research when we conduct a study is not to publish as many articles as we can, but to try to discover and disseminate the truth. So these authors suggest us some solution that are as a minimal cost on authors, readers, and reviews, but they suggest this solution, but they think it's very important to leave the right and responsibility of identify the way to conduct a research in the research that conducted the studies. The most things that the authors suggest us is to be transparent in description of method and statistical resource. Only in this way we can say the truth, and it's possible to replicate our study and reduce the possibility to commit false positive results.